Hello everyone, welcome back to my channel. Myself Diksha Gaur now. My next video is of dimension reduction. This is my 10th video now. In the previous videos we have seen the different types of topics which are covered the data science with Python. So the dimension reduction. Dimension reduction is a technique used to reduce the number of inputs, variables, or features in a dataset while retaining as much relevant information as possible. It is commonly used to tackle problems of high dimensional data where excessive features can lead to challenges like overfitting, increased computational complexity, and difficulty in visualization. So we can demonstrate that identify multicolor collinearity in Python. So the demonstration of how you will identify multicollinearity in Python. Multicollinearity occurs when two or more independent variables in a regression model are highly correlated, making it difficult to determine their individual effects on the independent variable. It can lead to unstable coefficients estimates. This is the example of collinearity that occurs between two or more independent variables in regression models. So we import the pandas as PD and import states models and these imports state models dot states that outlier influencer as INF. So once the dataset is in Python, pull out the three predictor variables and put them in their own data frame. Then call the data frame as X. Then we call the X data frame as PD dot data frame. This is the example of the data frame. Now that we have the predictor variables all together, use the scatter matrix command with X as the input to create a scatter plot matrix. Then scatter plot matrix dot pd dot plotting dot scatter matrix X. Then X is equals to X dot drop now. Then make sure you add the constant term in the X data frame. X X is equals to sm dot add, that is constant X value. Finally, run the variance inflation factor command as given below to obtain the VIF values for all four columns in the X data frame. So, by the help of the variance inflation factor command, with this command, we obtain the VI values for the four columns which we get in the data frame X. So this is the code for the this is the code for to identify multicollinearity in Python. Now the next one is to demonstrate how you will apply principal components analysis using Python. Apply principal components analysis in Python as PCA. Principal component analysis (PCA) is a dimension reduction technique used to transform high dimensional data into a lower dimensional form while retaining the maximum variance. Here's how to apply PCA in Python using sklearn, that is scikit-learn. So importing libraries by the help of the pandas, NumPy, scikit-learn, we import the libraries. So import NumPy as NP, import pandas as PD from the sklearn dot decomposition import PC. From sklearn dot preprocessing import standard scalar import matplotlib dot pyplot as PLT, that is the sample dataset we have taken the data that feature 1 and feature 2 the numbers, and now df is equals to pd dot data frames as the data, and for these the step first is to standardizing the data. To standardize the data we have taken here example of scalar, that is the standard scalar data, that the scalar fit transform df. Now step 2 is applying PCA. Now we apply the PCA value, that is the principal component analysis. So to apply PCA. PCA is equals to PCA and components to specify the number of components. Now principal components PCA dot fit transforms scaled data. Now for creating a data frame for PCA results, PCA PD data frame, that is the data principal components and column for PC1 and PC2. Then we will print the principal components as print PCA slash DF. Now the third step is explain variance ratio. To explain the variance ratio, we will use this command as print and explained variance ratio, then print PCA explained variance ratio. Then step 4 is to visualization. The visualization of this code is PLT feature. Then figure size is 8,6 split scatter PCA-DF PCA1 and PCA-DF PC2. Then we will declare the color and the alphabet letter. So here C is equals to blue and alpha is equals to 0.5. Now the title for this is PCA principal components. Now for the label of this plt.x label is principal component 1, then second one is principal component 2. Then we will show this result. So thank you so much. Let's see in the next video. Thank you.